Alright, so in this video we're going to talk about maps and drawing motion maps and then position, velocity, and acceleration maps. Alright, so we're going to observe the motion of a cart starting from rest and rolling down the ramp. The first thing we want to note is that this is our 0 and that this is our plus. So the positive direction, right, positive direction is increasing off of the paper here. Okay. It also has it here for our 0 and plus here. So if we're going to draw a motion map of the cart along the ramp, we're going to start positive. Our cart starts up here. We'll start here, and it starts off slow. Okay? Gravity has not had a lot of time to pull it down, so it starts off fairly slow, and then the arrows get bigger. Okay? So as our velocity increases, the size of our arrows also increase. Okay. Alright, so now is the velocity positive or negative? Okay, in this case, we want to make sure to refer back to that the positive direction is this way. Right? The positive direction is off of the motion map, and so our velocity is negative. It's going backwards away from the positive direction. So now is the acceleration positive or negative? Okay, so we want to look at what direction the positive direction is in, and then our velocity is increasing in the negative direction. So our velocity is increasing in a negative direction. And that means that the acceleration is negative. Alright, so we determined that the velocity and the acceleration were both negative. Okay. So now we want to predict the graphs describing the motion. Okay. So now it starts off positive, and it goes to 0. So we know our position is going to start off positive, it's going to go to 0. But how is it going to go to 0? Okay. Remember that the slope of a position versus time graph is the velocity. Okay. And our velocity is always going to be negative, so our slope is always going to be going down. But it starts really small and then gets bigger. So our slope is going to start negative, but not very steep. Okay, so it's going to start negative, not very steep, and then by the time it reaches this 0 point of the x-axis, right, it's going to be very steep. The arrow is going to be very large. So now that we've drawn the position versus time graph, we're going to draw the velocity versus time graph. Okay? We're going to look at the slopes right here and right here. Those are the tangent lines. Alright, so we decided that we had initially a very small slope, and as time goes on, the slope gets more and more negative. Okay, so initially in my velocity versus time graph, I have 0, and as time goes on, I get more negative. Okay, at every point along my position versus time curve, my velocity is negative. Right? And it's a linear increase. Okay? Now if I'm looking at my acceleration versus time graph, I have a linear velocity versus time graph. So I'm going to have a constant acceleration versus time graph. Right. Okay. When I have a curve in my position versus time, I have a linear velocity versus time and a constant acceleration versus time. So the slope of the position versus time is decreasing. Okay. And it's negative. The slope of the velocity versus time is constant and it's negative. Alright. So I have a negative acceleration that's constant, and I have a decreasing negative velocity. Okay. Alright. Alright, so in this problem, we have a ball rolling down a ramp. We want to draw the motion map along the ramp for the motion of the ball as it rolls towards the ramp from rest. Okay? So I start at rest. My v0 is 0. Okay. In this case, my x right here is 0, and my x as I go along is positive. So my x direction is positive going down the ramp. Okay. So I start off with a small velocity, and then as time goes on, my velocity gets larger in the positive direction. Okay. So now I want to draw the position versus time of this. Okay. So I start off at 0 and I go to 50. Right? But since my velocity is changing, I'm going to have a non-linear position versus time graph. Right? And initially I have a slow velocity and it gets bigger. So a slow velocity, that corresponds to a not very steep slope on my position versus time. Right? So that's why I know to draw the curve like that. Right? Initially, I have a slow velocity. So I have a slow positive velocity. Then it gets bigger as time goes on, and I get a bigger positive velocity. Okay. So initially my velocity is 0. My v0 right here is 0. And as time goes on, it gets bigger. It's linear. Okay. My acceleration, right? My acceleration is positive, but it's a constant positive. All right. So my acceleration is positive because I'm getting faster. My arrows are increasing in size in the positive x direction. All right. Okay, for number 8, we want to draw the motion map along the ramp for the motion of the ball as it rolls up and across the level section. Okay, so initially, my velocity is very large. Right, it's greater than 0. So as I start, I'm going to have a large velocity, and then I'm going to slow down. When I'm on this flat section, my velocity is going to be constant. Right, I'm not speeding up and I'm not slowing down. So I want to look at where my initial position is and where my positive direction is. So my positive x direction is along in this direction. Okay. So I start at 0 and I end at 50. But at 25, all right, at 25, I have something changing. So I initially start off very quickly and I slow down. Okay. So this large velocity right here, it indicates a large slope in my position versus time graph. And this slower velocity is a slower slope. Alright, so I have this kind of curve right here. And then it straightens out. So I start off very fast, I then slow down, and I go across the flat line. Okay. My velocity, it starts positive, goes down to a certain value, but it's still positive. Okay. So this is a curve. Alright. This is a straight line. So my velocity for this first part is slowing down, and it's positive. Right, my acceleration, if I look at my slope of my velocity versus time graph, it's negative. So I have a negative acceleration. And the slope for the second part is 0. So I have 0 acceleration. So when gravity is not acting on it, there's 0 acceleration, right? If I roll a ball along the floor, it's not going to speed up or slow down, it's just going to keep rolling. Alright, this will be the last 2 questions we have for the maps review. Okay. So my position versus time is non-linear. Alright, and we know off the bat that a non-linear position versus time means there's a non-zero acceleration versus time. So we should expect something where the acceleration versus time is non-zero. So it's not on this time axis right here. So I look at my slope right here, it's 0, and my slope right here, it's positive. So my velocity starts at 0, and it gets bigger. Right? This is a positive, bigger slope than that. It starts at 0, gets bigger. Right? So my velocity versus time graph, the slope of that line is constant, and it's positive. So for my motion map, I'm going to start, if this is 0, I'm going to start a little bit above 0. Okay? And I'm going to start off really slow, and I get bigger. Right? And remember, these tick marks represent meters. So this is 0 meters, 1 meter, 2 meters, 3 meters. The distance right here is 1 second. 1 second. 1 second. Okay? So the distance between the dots is 1 second, but where they're at on the tick marks is position. So the longer arrow means that the longer arrow means that you travel a farther distance in the same amount of time. So that means you have a faster velocity. So the length of the arrow corresponds to your velocity. Okay, let's look at this one. I have 2 sections separated by a dotted line. My first section is just like this graph over here. I have a 0 velocity to begin with and a positive velocity to end with. Okay, 0 to positive. Okay, all I'm doing is looking at the slopes at these 2 points. Okay. Now, the rest of this time, this entire length right here, that is a 0, it's a constant slope. Right? So it's constantly increasing. So my velocity is going to be constant. Right? My position versus time graph is non-linear here, non-linear, and it's linear here. Right? So when I look at my acceleration, I should already expect that in my non-linear portion, I'm going to have a non-zero acceleration versus time. And if I look here, it's positive. I'm going to leave my open circle. And then my linear portion, right? My linear, I know that if my position versus time is linear, I have no acceleration. And I can see that by looking at the slope of this line, this velocity versus time line. Okay. So for my motion map, what I want to draw is I start at 0 on my position versus time graph. Okay. I then start off slow, get faster, and then I stay at a constant speed. Right? My velocity is constant. Okay. And remember, this is 1 second. This distance right here is 1 second. And then this is 0 meters, 1 meter, 2 meters, 3 meters. Right, and that wraps up everything for our maps review.